In this video, we will discuss about the matrices in mathematics. In mathematics, to represent a collection of numbers, or objects, that follow a specific pattern, we use an array. Arrays are useful in quick data analysis and simple multiplication or division of large groups of objects. In the same way, if the numbers, or objects, are represented in a tabular form, that is rows and columns, then, we can represent them in a rectangular array, or matrix form. A matrix is a rectangular array of numbers, or symbols, or expressions, that are arranged in rows and columns. Matrices are very helpful in information storage and transmission. Watching Netflix web series? It uses matrices. The JPEG images of your recent vacation? It uses matrices. Playing PUBG mobile game? It uses matrices. At a very simple level, digital images are nothing but the spaced collection of pixels, or image elements, arranged in 2D space, which are represented as matrices. These matrices contain different integer values, which represents the level of brightness, or intensity, or similar properties. Matrices are usually written in parentheses or box brackets. The numbers, or symbols in the matrix, are called its entries, or its elements. The horizontal line of entries are called rows, and vertical line of entries are called columns. The size of the matrix is defined by the number of rows and columns it contains. A matrix with m rows and n columns is called m by n matrix. Matrices with a single row are called row matrices. Matrices with a single column are called column matrices. A matrix, having the same number of rows and columns, is called a square matrix. Determinant of a matrix. The determinant of a matrix is a mathematical object, or a scalar quantity, that is specially defined for square matrices. It describes important information about the matrix in a single number. It is very useful in the analysis and solution of systems of linear equations. The determinant of a matrix A is denoted by det A or delta. If A is a matrix containing elements A, B, C, D, then the determinant of A is denoted as the subtraction of the products of A, D, and B, C. The determinant of a 3 by 3 matrix A can be calculated as follows. Multiply the element A with the determinant of the 2 by 2 matrix that is not in A's row or column. And also do the same for element B and C. Add a negative sign to the B's value and sum up all the values. Transpose of a matrix. Transpose of a matrix is the flipped version of the original matrix A. The rows and columns of matrix A are switched to form the transpose of matrix. It is denoted as a power t. If the order of the matrix A is m by n, then the order of the transposed matrix is the n by m. Some of the examples are: the transpose of the row matrix having elements 1 and 2 is equal to the column matrix having 1 and 2. The transpose of a square matrix having elements 1, 2, 3 and 4 is equal to the square matrix having 1, 3, 2, and 4. The transpose of a 2 by 3 rectangular matrix, having elements 1, 2, 3, 4, 5 and 6, is equal to the rectangular matrix 3 by 2, having 1, 3, 5, 2, 4, 6. Properties of transpose matrices are: the transpose of a transpose matrix is equal to the original matrix. The transpose of addition of two matrices, A and B, is equal to the addition of transpose matrices, A and B individually. The transpose of multiplication of two matrices, A and B, is equal to the product of transpose matrices of A and B individually, but with the order reversed. The transpose of a scalar is equal to the same scalar. The determinant of a transpose matrix is equal to the determinant of the original matrix. Identity matrix. A square matrix, that has ones in its diagonal, and zeros elsewhere, is called an identity matrix or unit matrix. It is denoted with I, n by n. For example, a 2 by 2 identity matrix is denoted with I, 2 by 2, and a 3 by 3 identity matrix is denoted with I, 3 by 3. Inverse of a matrix. A matrix A of order n by n is called invertible if there exists another matrix B of order n by n such that AB equals BA equals IN. Here, IN is the identity matrix of order n by n. Then, the matrix B is called the inverse of A, which is denoted by A power minus 1. The inverse of a matrix A can be found using the ratio of adjoint A to the determinant of A. The adjoint of A is also called the adjugate of A. The adjugate of A is the transpose of the cofactor matrix of A. The cofactor matrix can be found as follows. In the cofactor matrix, the element A can be found using the determinant of 2 by 2 matrix that is not in the A's row or column. The element B is found using the negative determinant of the 2 by 2 matrix that is not in the B's row or column. The element C is found using the determinant of the 2 by 2 matrix that is not in the C's row or column. In the same way, all the remaining elements of the cofactor matrix will be found using determinants of the corresponding 2 by 2 matrices. Here the cofactor elements, D, F, and H will get negative sign for their result. The transpose of an invertible matrix is also invertible. And its inverse is the transpose of the inverse of the original matrix. In this video, we have discussed about the matrices in mathematics.